to an intriguing exploration into the science behind one of the most ubiquitous adhesives in our lives, superglue. To truly appreciate its marvels, we must first travel back in time to the era of World War II, a period marked by innovation and necessity. It was in this crucible of invention that superglue was born, though not for the purposes you might expect. The story begins with a chemist named Harry Coover, who was working on developing clear plastic gun sights for the war effort. In 1942, while experimenting with various compounds, Coover stumbled upon a substance called cyanoacrylate. At first glance, this sticky compound seemed more of a nuisance than a breakthrough, as it adhered to everything it touched. Little did he know, this accidental discovery would later revolutionize the way we bond materials together. Initially dismissed due to its overly adhesive nature, cyanoacrylate was shelved for years. It wasn't until 1951, nearly a decade later, that Coover revisited his earlier work. This time, he recognized the potential of cyanoacrylate as a commercial adhesive, capable of bonding almost any material rapidly and securely. This marked the official birth of what we now know as superglue. The impact of this discovery cannot be overstated. Superglue's ability to form a strong bond in mere seconds opened up a world of possibilities, from household repairs to industrial applications. But it wasn't just the speed of adhesion that made superglue remarkable. It was the strength of the bond itself. A tiny drop could support immense weights, a testament to the revolutionary nature of Coover's accidental find. As we delve deeper into the science behind superglue, we will uncover the fascinating chemistry that makes it such a powerful adhesive. For now, let's pause to appreciate the serendipity of its origins, a chance discovery during wartime research that has since become an indispensable tool in our everyday lives. Join us as we continue this journey, unraveling the complexities of superglue's chemical composition and exploring its myriad applications across various fields. From the historical roots of its creation to its modern-day uses, the story of superglue is one of innovation, persistence, and unexpected brilliance. Now let's dive into the fascinating chemistry that makes superglue so effective. It all starts with monomer molecules, the building blocks of this remarkable adhesive. When you open a tube of superglue, these monomers are in a liquid state, eager to interact with the world around them. It's the exposure to moisture in the air that triggers a transformation. As soon as the glue encounters moisture, the monomer molecules begin to link together, forming long chains known as polymers. This process is called polymerization, and it happens incredibly fast. In a matter of seconds, these chains interlock, creating a solid, durable bond. This is why superglue is known for its rapid setting time, often hardening within 10 to 30 seconds. The magic lies in the chemical composition of these monomers. Cyanoacrylate, the primary component of superglue, is a type of acrylic resin. Its unique structure allows it to react quickly with water, leading to the formation of these robust polymer chains. This reaction is exothermic, meaning it releases heat. But why does it bond so well to almost anything? The secret is in its ability to fill microscopic gaps on surfaces. As the liquid monomers seep into these tiny crevices, they expand and harden, creating a grip that is tough to break. This is why superglue is used in a wide range of applications. However, while superglue is incredibly strong, it's not without its limitations. The very nature of its rapid bonding can sometimes be a drawback. Once it sets, it's nearly impossible to reposition or adjust, which can be challenging in precise applications. Additionally, its strength is best suited for rigid materials. Understanding the chemical mechanism of superglue not only highlights its strengths, but also its potential weaknesses. This knowledge empowers us to use it more effectively. Whether you're fixing a broken vase or assembling a model airplane, knowing how superglue works can make all the difference in achieving a successful bond. In summary, the science of superglue is a testament to the power of chemistry in everyday life. From its rapid polymerization process to its ability to bond diverse materials, superglue's effectiveness is rooted in its chemical makeup. As we continue our exploration, we'll uncover even more about its applications and limitations. Superglue's versatility is truly remarkable, finding its place in a wide array of fields and applications. Let's delve into some of the most fascinating uses of this powerful adhesive. In the world of crafting, superglue is a staple. Its ability to bond materials quickly and securely makes it indispensable for DIY enthusiasts and professional artisans alike. Whether it's assembling intricate models or repairing broken ceramics, superglue offers a reliable solution that stands the test of time. In the medical field, superglue takes on an even more critical role. Known in medical circles as cyanoacrylate adhesive, it's used for closing wounds and surgical incisions. This application reduces the need for traditional sutures, promoting faster healing and minimizing scarring. Imagine the convenience and comfort it brings to patients, allowing them to recover with less discomfort and a quicker return to their daily lives. Beyond crafting and medicine, superglue also plays a crucial role in forensic science. One of its most intriguing applications is its ability to lift fingerprints. In crime scene investigations, superglue fumes are used to develop latent fingerprints on non-porous surfaces. This process, known as cyanoacrylate fuming, reveals fingerprints that are otherwise invisible to the naked eye, providing critical evidence in solving crimes. The science behind this application is as captivating as it is effective. When heated, superglue releases fumes that adhere to the moisture and oils present in fingerprint residues. This reaction forms a hard, white polymer that outlines the fingerprint pattern, making it visible for analysis. It's a testament to how a simple household adhesive can contribute to the pursuit of justice. Moreover, superglue's application extends into the automotive industry, where it's used for quick repairs on various car parts. Its rapid bonding capability ensures that minor fixes can be addressed promptly, keeping vehicles in optimal condition without the need for lengthy repair times. In the realm of electronics, superglue is used to secure components and protect delicate circuitry. Its precision and strength make it ideal for tasks where accuracy is paramount, ensuring that devices remain functional and durable. From the everyday to the extraordinary, superglue demonstrates an ability to adapt to diverse needs and challenges. Its applications are as varied as they are ingenious, offering solutions that enhance both our personal and professional lives. As we continue to explore the potential of this adhesive, the possibilities seem limitless. Whether in the hands of a skilled craftsman, a medical professional, or a forensic expert, superglue proves time and again that it is an invaluable tool in our modern world. In our journey through the world of superglue, we've uncovered its historical roots and marveled at the chemistry that allows it to bond almost anything in mere seconds. Now let's take a closer look at the strengths and weaknesses that define this remarkable adhesive. Superglue is celebrated for its incredible tensile strength. Imagine a single drop of this adhesive holding together materials with a combined weight of over 3 tons. This strength is due to the robust polymer chains that form when the glue sets, creating a bond that is both powerful and enduring. It's this very property that makes superglue a staple in industries ranging from construction to aerospace, where reliable adhesion is paramount. However, like all great inventions, superglue is not without its limitations. Despite its impressive ability to hold, it can be surprisingly brittle. This brittleness means that while it excels in tension, it can struggle under shear forces or impact. Imagine a tightly bonded joint shattering under a sudden blow. This is where superglue's limitations become apparent. Additionally, superglue's performance can vary depending on the materials it is used on. While it bonds exceptionally well with non-porous surfaces like metals and plastics, it can be less effective on porous materials, such as fabric or wood, where the adhesive can be absorbed, reducing its effectiveness. The adhesive's susceptibility to moisture and temperature changes also plays a role in its limitations. In environments with high humidity or extreme temperatures, the bond can weaken, compromising its integrity. These factors must be considered when choosing superglue for specific applications, ensuring that the conditions align with its optimal performance range. Understanding these strengths and weaknesses is crucial not only for everyday users, but also for industries that rely on precision and reliability. By acknowledging both the capabilities and the constraints of superglue, we can better harness its potential, applying it where it shines the brightest and avoiding scenarios where it might falter. As we continue to explore the science behind superglue, we gain a deeper appreciation for its role in modern life. From simple household repairs to complex industrial applications, this adhesive has cemented its place as a tool of choice for many. Yet knowing when and how to use it effectively is key to unlocking its full potential. In our next segment, we'll wrap up our exploration by revisiting the highlights of our journey, reflecting on the fascinating intersections of science, history, and practical application that make superglue such a unique and indispensable part of our world today. As we conclude our exploration into the science of superglue, let's take a moment to reflect on the journey we've taken. From its serendipitous discovery during World War II by chemist Harry Coover, to understanding the intricate chemistry that allows it to bond so swiftly and effectively. We've seen how superglue's applications span from the creative world of crafting to the critical fields of medical and forensic science. Yet, despite its incredible tensile strength, we also recognize its limitations, such as its brittleness under certain conditions. This journey has unveiled not just the science, but the profound impact superglue has had on various industries and everyday life. We hope this deep dive has enriched your understanding and appreciation for this remarkable adhesive. Thank you for joining us, and may you look at that tiny tube of superglue with newfound respect and curiosity. Remember, the world of science is all around us, waiting to be explored. Until next time, keep discovering and stay curious.